This is Chapter 3, Lesson 7, Solve Systems of Equations by Graphing. Two or more equations with the same set of variables are called a blank, blank, blank. For example, y equals 4x and y equals 4x plus 2 together are a system of equations. Okay, so in those three blanks, you're going to write system of equations. You can estimate the solution of a system of equations by graphing the equations on the same coordinate plane. The ordered pair for the point of intersection of the graphs is the solution of the system because the point of intersection simultaneously satisfies both equations. So basically that point is the answer. That's what you're looking for. You're looking for where they intersect. Okay? So let's take a look at some examples. The first example I have here says, solve the system y equals negative 2x minus 3 and y equals 2x plus 5 by graphing. So I graph each equation. Okay. So here's y equals negative 2x minus 3. It's right here. Okay. And y equals 2x plus 5. The point where they intersect, right here, is going to be my solution. So the graphs intersect at negative 2, 1. I can always check this by replacing negative 2 and 1 into both of my equations. So the first one I check 1 equals 1, and the second one I check 1 equals 1. So the solution is negative 2 minus 1. Okay. Number 2 says Gregory's Motorsports has motorcycles, 2 wheels, and ATVs, 4 wheels in stock. The store has a total of 45 vehicles that together have 130 wheels. Write a system of equations that represents the situation. Okay, so we're going to write the system. Okay, let y represent the motorcycles and x represent the ATVs. Okay, so the first thing I'm looking at is the store has a total of 48 vehicles. Okay, so that means if I add y plus x, that equals 45. So there's my first one. Okay. The second thing I have is there's 130 wheels, right? So I'm going to take 2, motorcycles have 2 wheels, 2 times y, because that's my motorcycles, plus 4 times x, which are my ATVs, equals 130. So those are my 2 equations. For example number 3, it says solve the system of equations, interpret the solution. So I'm going to write each equation in slope-intercept form. So the 2 equations they give me, x plus y equals 45, and 2y plus 4x equals 130. So those are the equations we came up with in example number 2. So I'm going to change x plus y equals 45, so it's y equals negative x plus 45. All I did was subtract x from both sides. For 2y plus 4x equals 130, I subtracted 4x, and then I divided everything by 2. So I got y equals negative 2x plus 65. Okay? Then I can graph both of those equations. Okay? So here's my first equation. Here's my second equation. I can graph both of those. Here's my first one right here. Here's my second equation. The point where they intersect is 20, 25. So the solution is 20, 25. This means that the store has 20 ATVs and 25 motorcycles. Okay, so that's actually what it means. You can always check your results. Okay. There are 3 try problems on this page. Go ahead, pause the video, try them out, and when you are done, we will go over the answers together. All right, now that you've tried the try problems on your own, let's go over the answers together. So letter A says y equals x minus 1 and y equals 2x minus 2. So I want to solve this system of equations by graphing. Okay, so here's my first, here's my second. Okay, so I'm going to go ahead and graph these 2 equations. So I start at -1, which is right here. Go up 1 over 1. There's my 2 points. Okay, straight edge. Okay. Then my second one is -2. I start here. I go up 2 over 1. It's nice and convenient. Okay. So the point where they intersect is right there. So my answer for letter A is going to be 1, 0. Okay. Letter B, y equals 4x, y equals x plus 3. I'm going to solve them graphically. Okay. So my 2 equations. So I start here at 0, 0. My first one, I go up 4 over 1. So right there. And my second one, I start at +3, and I go up 1 over 1. And they cross right there. So my solution is 1, 4. Okay. Letter C says Creative Crafts gives scrapbooking lessons for $15 per hour plus $10 supply charge. Scrapbooks Incorporated gives lessons for $20 per hour with no additional cost. Write and solve a system of linear equations that represents the situation. Interpret the solution. Okay, so my first equation, $15 per hour, right? So y equals, so y is, okay, scrapbooking lesson $15 per hour plus a $10 supply charge. So 15x plus 10 is my first equation. And y equals 20x plus 0 is my second equation. Okay, so I'm going to go ahead and graph these 2 equations. So the first equation I got $15 per hour, so x is my hours, y is my total cost. That's where I got the 2 equations from. So the first one I have is I start at +10. +10, I go up 15 and over 1. Okay. So that's where I can start. Okay, the second one, I start at 0, 0. I go up 20 over to 1. Okay. So they actually cross right there. So at 2, 40 is the point that they cross at. Okay, so this tells me if you take lessons for 2 hours, the cost will be $40 at both places. Okay? All right, second half of this lesson talks about solutions that we could possibly have. So there are 3 different solutions that we could have. So number of solutions. The graph of a system of equation indicates the number of solutions that we possibly have. If the lines intersect, there is 1 solution. Okay. If the lines are parallel, so it means they never touch, there is no solution. And if the lines are the same, there are an infinite number of solutions. Okay? Goes on without end because they're the same exact line. Doesn't matter what number you plug in, and it will work for both equations that are given. Okay? So let's look at a couple of examples. Example number 4 gives us the following equations: y equals 2x plus 1 and y equals 2x minus 3. Okay. So I graph the equations on the same coordinate plane. They are parallel. Okay. They never intersect. They appear to be parallel. So that means that there is no solution that will work for both of these equations. Okay. The other thing that you can recognize is that they have the same slope. These 2 equations have the same slope, but they have different y-intercepts. So that's a good indication that they will be parallel. Okay. Number 5. So look at this one. Okay. 5 says y equals 2x plus 1 and y minus 3 equals 2x minus 2. Okay. When I solve y minus 3 equals 2x minus 2, I get y equals 2x plus 1. So they're the same line. I'm going to graph them. They're the same line though. Okay. So that means there is an infinite number of solutions. Infinite number, because they're the exact same line. Okay. Problem number 6. Systems of equations consist of 2 lines. One line passes through 2, 3 and 0, 5. The other line passes through 1, 1 and 0, -1. Determine if the system has no solution, 1 solution, or an infinite number of solutions. Okay, so I solve for my slopes for each of my 2 lines. The slope of my first line is -1. Slope of my second line is 2. And then can go ahead and put them in point or y-intercept. I can find the y-intercept and put them in. So the 0.05, my y-intercept is 5. And for 0, -1, my y-intercept is -1. Okay. So nice thing is I had zeros in both of those up top, so I could use those as my y-intercepts. So that was really nice. Okay, I didn't have to actually put them in point slope form to do that. Okay. So my 2 equations, y equals -1x plus 5, y equals 2x minus 1. I graph them. They do intersect at 1 point, so there is 1 solution. And the solution is 2, 3. Okay. There are 3 more try it problems down below. Go ahead, pause the video, try out the try it problems. When you are done, we will go over the answers together. All right, now that you've tried the try it problems on your own, let's go over the answers together. So letter D. Again, I'm solving all of these systems of equations by graphing. Okay, so letter D says y equals 2/3 x plus 3, and 3y minus 2x. 3y equals 2x plus 15. Okay, so the first thing that I want to do. So here's my first one. This one is not in slope-intercept form, so I'm going to change it to slope-intercept form. Okay. That requires me dividing both sides by 3. So I get 2/3 x plus 5. Okay, so that's my second equation now. I also notice I have 2/3 and 2/3, which means probably going to be parallel, but we can double check and make sure by graphing. So my first one, y equals 2/3 x plus 3. I go up to 3. Then I go up 2 over 3. Here's my first line. My second line was plus 5. Then I go up 2 over 3. So I do get 2 parallel lines. So this one has no solution. Okay. Letter E, y minus x equals 1 and y equals x minus 2 plus 3. Okay, so I need to solve both of these equations. So my first one, I want to get y by itself, so I add x to both sides. So this is y equals x plus 1, and this one's y equals x plus 1. They're the same equation, which means I'm going to have an infinite number of solutions. So when I graph this, plus 1, up 1, over 1. Here's my line. Okay. And there is only going to be 1 because they're both the same equation. So infinite solutions. Okay. Second one I'm given 2 sets of coordinate points. So I need to find my slope. For each of these, so I have 4 minus 2 over 1 minus 0, which is 2 over 1, and then 1 minus negative 1 over 1 minus 0, so that's 2 over 1. Okay. So they both have a slope of 2. My first equation, okay. First equation, so I get y equals 2x plus 2. My second equation, y equals 2x minus 1. They have the same slope, so they're probably going to be parallel. Go ahead and graph them anyway. Plus 2, up 2 over 2. Okay, here's my first one. Okay, second one, minus 1. Right there, up 2 over 2. They are parallel, so this one has no solution. Okay, and on the next page are a couple of foldables that we have. So the first foldable I want to talk about is the yellow one. It says how to solve a linear system by graphing. Okay, so it gives you 3 examples. Okay, it also talks about some steps that you can use. Okay, so All right, so there are 3 steps when I'm solving a linear system by graphing. So step 1 is rewrite each equation in slope intercept form. Okay, so rewrite each equation in slope intercept form. So that's that y equals mx plus b form. Okay, step 2 is graph each line independently. Okay, so graph each line. Step 3 is to identify the point of intersection. Okay. So they give us 3 examples. Let's work on them. So example number 1 is y equals 1/3 x minus 2. 3y equals negative 2x plus 3. This is in slope-intercept form, but this is not. So I'm going to go ahead and solve this one for slope-intercept form, which is dividing this by 3. So I get y equals negative 2/3 x plus 1. Okay, so there's my 2 equations. So this is equation 1. Here's my equation number 2. Okay, now I'm going to go ahead and graph each of those equations. Okay, so my first equation, start at minus 2, and I go up 1 over 3, up 1 over 3. Okay, I can go ahead and so there's my first equation. My second equation, negative 2/3 x plus 1. So I start at plus 1. I go down 2 over 3. So there's my point of intersection right there, which is really nice. Okay. So there's my point of intersection, which is 1, 2, 3, 3, comma, negative 1. Okay. Example number 2 says negative x plus y equals 1 and x plus 2y equals 8. Neither of these are in slope-intercept form, so I need to solve them both. Negative x plus y equals 1. I just add x to both sides, so I get y equals x plus 1. Okay. Then my second one, x plus 2y equals 8. I subtract x from both sides, so I get 2y equals negative x plus 8, and then divide by 2. So I get y equals negative 1/2 x plus 4. So there's my 2 equations. Equation 1, equation 2. I'll go ahead and graph both of these. So go up 4, 1, 2, 3, 4, then down 1 over 2, down 1 over 2. So there's one of my lines. There's my orange line. Doesn't matter which equation you start with, completely up to you. Okay, you will should still get the same result regardless. So then I have plus 1, then up 1 over 1, up 1 over 1. Okay, so here's my point of intersection right there. So that's 1, 2, 2, comma, 1, 2, 3. 2, comma, 3 is my point of intersection. example number 3 says x plus 4y equals 12 and 7x plus 4y equals negative 12. Okay, so again, neither of these are in slope-intercept form, so we need to solve them for that. Subtract x, 4y equals negative x plus 12, divide by 4, y equals negative 1/4 x plus 3. Okay, and then the second equation, 7x plus 4y equals negative 12. Subtract 7x, 4y equals negative 7x minus 12. Divide by 4, so y equals negative 7/4 x minus 3. Okay, so I start with negative 3. 1, 2, 3. So there's my first point down here. Okay. All right, so I'm going to go opposite way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So there's my point. Okay, then my other equation, plus 3, 3, down 1, 4, I can also go up 1. 1, 2, 3, 4. There's my point of intersection right there. Okay, so my point of intersection is right there. So it is 1, 2, 3, negative 4, comma, 1, 2, 3, 4. Negative 4, comma, 4. Okay? So that's the yellow foldable. Okay? Then we also have the blue foldable. Okay, the blue foldable shows us some examples of one solutions, no solutions, and infinitely many solutions. Okay, so one solution, I'm going to use a graph. Okay, we're going to talk about substitution or elimination later, but I'm just going to use the graph for right now. Okay, so again, I need to solve these and make sure that they are in slope-intercept form. So the first one I have, subtract x, negative 3y equals negative x minus 9, divide by negative 3. So I get 1/3 x plus 3. And my second equation, I'm going to subtract x. Basically, all I did was multiply by negative 1 here, okay? So those are my two equations. I'm going to go ahead and graph them on my graph over here. So the first one I have is x plus 1. So up 1 over 1, up 1 over 1. Okay, so this has my line. It's always nice to have a straight edge or a ruler handy when you're graphing, because that you make sure you've got nice straight lines, which makes your graph more accurate. Okay. And then I have 1/3 x plus 3. 1, 2, 3, up 1 over 3. So there's my two equations. They do meet at that point. So my solution is 1, 2, 3, 1, 2, 3, 4, 3, 4. Okay, so there is only one solution. Okay, no solutions. I have x minus y equals -4, negative 3x plus 3y equals -6. So no solution. These are going to be parallel lines. Okay, again, I'm going to solve. So I have slope intercept. Okay, so there's my first equation. Okay, so there's my two equations. Y equals x minus 4 and y equals x minus 2. Again, they have the same slope, which means they're most likely going to be parallel. Okay, we do know that that's the case because we're talking about no solutions. So I've got -2, up 1 over 1, up 1 over 1. Okay. And then my other equation was x minus 4. Okay. Up 1 over 1. Excuse me. So they are parallel. Okay. So that means there is no solution. Parallel lines. Okay. Last one I have is infinitely many solutions. So again, I have two equations, neither of which are in slope-intercept form. So I'm going to go ahead and solve this. Okay, so there's my first one, y equals -3x plus 2. Again, they're the same line, so it's going to be infinitely many solutions. Plus 2 down 1 over 3. Okay, because they are the same line. They have an infinite number of solutions because they're the same line. Okay, so those are 3 examples for one solution, no solution, and infinitely many solutions. We will actually revisit this because it does talk about substitution or elimination, which we talk about in the next lesson.